Continuing the discussion for the common emitter, emitter stabilized configuration, i-discuss natin ngayon ang R sub E model naman ng isang fully bypassed circuit. Last time, we have discussed the unbypassed configuration. So tignan natin ano magiging differences based on the AC parameters of the fully bypassed and ang unbypassed configuration. Itong circuit na to, this is an emitter stabilized configuration, again using an NPN-BJT, but this time meron tayong bypass capacitor that is connected in parallel with your R sub E. Under DC analysis, wala namang magiging effect itong bypass capacitor natin kasi under DC conditions, all capacitors are considered to be open circuit. So, walang magiging epekto under DC. Sa AC, magkakaroon siya ng effect. Later on, makikita natin yung magiging effect niya, So, balik tayo dun sa R sub E model na na-derive natin sa ating previous lecture. This one is your R sub E model para sa common emitter configuration. Yan, let me just change this one. Yan. So, itong part na yan, this is the R sub E model of your common emitter configuration. And then, we connected external resistors sa kanyang mga terminals. Kapag zinero out natin lahat ng mga DC values, kagaya ng ating VCC, mako-connect na sa pagitan ng base at ground ang ating R sub B, at sa pagitan ng collector at ground ang ating R sub C. Familiar naman tayo kung paano natin madederive itong ganitong klaseng model or ganitong klaseng figure or schematic, dahil na-discuss natin ito last time. But this time, anong mangyari dun sa ating R sub E? It will be shorted out. So as you noticed here, wala na yung ating R sub E. Bakit? Dahil under AC conditions, ang capacitors are assumed to be short circuit. So ibalik natin dun sa ating figure. So this will become a short circuit under AC condition because we have the equation for the capacitive reactance, diba? Diniscuss natin yan before. That's 1 over 2 pi FC. So kapag mataas yung frequency natin, what happens to X sub C or the impedance? Bumababa. So kapag tumaas ang frequency, nagiging mababang impedance or ang ating reactance, nagiging wire na lang siya. In effect, nasa-short out itong ating R sub E, because of the shorting out of the bypass capacitor. Kaya pagdating dito sa ating R sub E model, wala na ngayon yung ating R sub E. Short circuit na lang ang makikita natin. Let us now derive the equations for the input voltage. For the input voltage equation, we have V sub I is equal to I sub B times beta RE. So, bakit naging ganito yung ating equation? Balik lang natin dun sa ating previous slide. Alright? So, as you notice here, nag-apply tayo ng input voltage V sub I between the base and the ground. Therefore, ang voltahe natin, ang AC voltage between the base and ground, this part and this part, is also equal to V sub I then. Alright? So, anong nakikita ba natin na resistance dito sa part na to? Hindi ba't yung beta RE lang? Kasi nga yung ating R sub B kanina, na-short out na because of the bypass capacitor under AC conditions. Therefore, ang ating input voltage is directly applied to your beta R sub E. Ang magiging voltahe natin dito sa part na to, so let me just erase this part, para makita natin, So, this is V sub I. And also, this is V sub I then. Alright? So, kaya ang formula natin for V sub I is I sub B, which is this one, times beta R sub E. And as you notice, na pumasok yung kuryente sa positive polarity ng input voltage, that's why we have a positive equation for that. Ayan. And the next one, But beta RE is also equal to Z sub B. So bakit equal siya sa Z sub B? Remember, ang Z sub B is the impedance measured at the base terminal of your transistor. Eh ano lang bang nakikita natin dito sa part na to, no? Sa base terminal ng ating transistor. Hindi ba't yung beta RE lang? Therefore, Z sub B is also equal to beta RE. Sa previous natin, dun sa unbypass, no, we derived the equation for Z sub B. So in this case, na-simplify yung equation natin for Z sub B because of the bypass capacitor. Alright. And then, we're going to equate the two equations for the input voltage. You have I sub B, beta RE, which is this one. That is also equal to I sub B times Z sub B. Ma-eliminate natin dito yung I sub B. Ang matitira na lang dito is Z sub B is equal to beta RE. So that's just a proof, no, na ang Z sub B ay equal sa beta R sub E. Right. So we are now going to determine Z sub I. So to determine Z sub I, as you notice here, we have R sub B parallel with Z sub B. So parang sa dating discussion natin, sa previous discussion natin, no, dun sa unbypassed configuration. So nakaparallel ang R sub B sa ating Z sub B. And as you notice here, directly nakakonect yung both ends ng R sub B tsaka ng ating beta RE, which is a characteristic of a parallel connection. And then Z sub I, kukunin lang natin yung parallel combination nung dalawang resistances na yon. Alright. So Z sub I is equal to R sub B parallel with Z sub B. Yan. And since Z sub B is equal to beta RE, pwede natin palitan to ng beta RE. It's simpler compared dun sa ating unbypassed configuration, pero tignan natin ano ba magiging effect nito, no, pagdating sa output voltage natin. Alright. Next, we're going to determine the output impedance R sub C. This is the same with unbypass, no? Kasi susukatin natin on this side yung ating output impedance, no? Ano lang bang nakikita natin dito? Hindi ba't yung R sub C lang? Alright? That's why Z sub O is equal to R sub C. And then next one, we're going to determine the voltage gain, A sub V. In order for us to determine the voltage gain A sub V, kailangan natin makuha yung equation for the output voltage and the input voltage. So dito muna tayo sa output na. Yan. So, meron na pala tayong ano doon. Yan. So, we have positive and negative V out or the output AC voltage. So, ito yung expected natin na naka-amplify. This is the amplified version of your input. Alright. Since lumalabas yung ating kuryente dito sa ating positive terminal, ang equation natin for this voltage should be negative or should have a negative sign or symbol. So, the output voltage is equal to the output current times R sub C. Kasi ang output current natin dumaraan sa R sub C, di ba I times R is equal to V. So, this is the equation. No? Meron tayong negative dito dahil lumalabas yung kuryente sa ating positive polarity for the output voltage. And I sub O is also equal to I sub C, di ba? So, same lang yan, no? Ito yung I sub O natin, pumasok dito. This is also I sub C. That's why we can replace the equation, or rather I sub O, with I sub C. And then the equation for the input voltage. So, kanina naman na-derive natin ito, no? So, V sub I, or the input voltage, is equal to I sub B times the impedance at the base Z sub B. And then, isa-substitute natin ito para sa ating voltage gain equation. Output voltage divided by the input voltage lang. So, i-replace natin yung output voltage with this equation. Kaya meron tayo ngayong ganito. And we will replace the input voltage equation ng ganito. Kaya meron tayong ganitong equation sa, or rather term sa denominator. And then IC over IB is equal to beta. Kaya we can replace IC over IB here. Magiging beta na siya. So negative beta RC over Z sub B. But Z sub B is equal to beta R sub E. So ito yung na-derive natin kanina, no? So we just replace and substitute the terms with the corresponding values na ating na-derive earlier. Therefore, the voltage gain of a fully bypassed common emitter biased configuration is equal to negative RC over R sub E, which is different compared sa unbypassed configuration na diniscuss natin sa previous video natin, no? Again, yung negative symbol here, it doesn't mean na nag-decrease yung ating output. It means na meron tayong phase shift ng 180 degrees. Alright, so let's have an example. Actually, this is the same example I gave sa ating previous discussion, no? Same values pa rin, pero magkakaroon tayo ngayon ng coupling capacitor, no? Connect the bypass, magkakaroon tayo ng bypass capacitor C sub E, no? So connect natin yung bypass capacitor natin dito, nakaparallel na, no? So alam natin under AC condition, itong ating 0.56 kilo ohm na resistor ay masya-short, no? Under AC condition, but under DC walang problema dyan kasi open circuit ang capacitor under DC condition. So let's solve first for R sub E. To solve for R sub E, by the way, ito muna, no, yung ating R sub E model. I-drawing muna natin siya. As you noticed here, wala na yung R sub E natin. Okay, kasi na-short out na siya because of the bypass capacitor. So, ilalagay lang natin yung mga values, 470K for RB and 2.2K for RC. Right. For I sub E, wala rin pinagkaiba ito dun sa unbypass kasi nga, kagaya ng sabi ko, walang epekto ang capacitor under DC conditions. Naka-open lang naman lahat ng capacitors under DC. That's why ang ating R sub E is the same with the unbypassed, no? 5.99. Ito yung na-calculate natin last time, no? For letter B, the input impedance, ito magkakaroon na tayo ng difference. Kasi iba na yung equation natin for the input impedance, no? Rather for Z sub B, no? Ang Z sub B natin ngayon is beta times R sub E. That is equal to 718.8 ohms. Ipaparallel natin yung RB tsaka yung Z sub B to get Z sub I. And then we have 717.7 ohms para sa ating input impedance. But for the unbypassed, meron tayong 59.34 kilo ohms. So mas bumaba yung ating input impedance because of the bypass capacitor. For the output impedance, it's the same with unbypassed. So that's equal to R sub C, which is equal to 2.2 kilo ohms. For the gain, so dito na tayo magkakatalo ngayon sa ating gain, no? Isa-substitute lang natin yung values for R sub C and R sub E. R sub C is 2.2 kilo ohms. Ang R sub E natin is 5.99 ohms. So the voltage gain is equal to negative 367.28. Sa unbypassed na na-calculate natin last time, kita nyo ang baba. So sobrang layo ng difference ng gain, ng voltage gain ng unbypassed configuration tsaka ng fully bypassed configuration. So tignan nyo naman, no? Hundreds, no? Yung difference nila in terms of the voltage gain, no? For example, meron tayong input voltage na, let's say, 10 millivolts, no? Ang ating input voltage, let's say 10 millivolts, RMS na lang ulit, no? Para hindi tayo maguluhan dun sa polarity. What would be the corresponding output voltage? As I've said before, ang output voltage natin makukuha pag minultiply ang input sa gain. So, input voltage times the gain is equal to output voltage. So, we will have a 3,672.8 millivolts, or roughly that is equal to 3.67 volts. So imagine niyo, no, from 10 millivolts naging 3.67 volts na siya. So tumataas yung gain natin kapag meron tayong bypass capacitor. But the disadvantage with the fully bypass configuration, mataas nga yung gain, but the output is hindi siya ganun ka-stable. Unlike sa ating unbypassed configuration, mas stable siya, no? So, nagkakaroon tayo ng less variation sa positive tsaka sa negative half cycles ng ating output signal. Dito, posibleng yung negative half cycle natin is mas malaki compared sa ating positive half cycle, no? So, nagkakaroon tayo ng unstable output pero mataas naman yung gain. So, anong pwede natin gamitin dito sa dalawang to? Meron tayong tinatawag na split emitter configuration. Yung R sub E natin ay nahati sa two parts, no? We have R sub E1 tsaka R sub E2. Yung R sub E1 is unbypassed and then yung R sub E2 is fully bypassed. So we call that the split emitter. Yun ang nakakuha ng magandang characteristics ng dalawang to, no? Ang gain nun, hindi ganun kataas, pero stable yung output. Sa split emitter, ang gain niya is nasa pagitan ng unbypassed tsaka ng fully bypassed. But the output is stable enough. Okay? So this is just a comparison between the two outputs, input, naka-superimpose yung input tsaka yung output natin, no? This one on the left side, this is yung blue sine wave, this represents the input for the unbypassed configuration. And the red sine wave, it represents the output. Kung mapapansin natin, no, dun sa ating output, nag-amplify naman siya and we have a 180-degree phase shift, no? Kung positive half cycle to, negative half cycle naman yung output natin but amplified, no? Ito yung output natin ng unbypassed configuration. Ito naman on the right side, this is the input, yung blue, almost parang na siya, parang straight line dahil sa sobrang liit, no, nung input natin and sa sobrang laki ng output natin. But in reality, etong kulay blue na to, ganito rin naman yung itsura niya. Sobrang liit na lang siya dahil yung output natin ay sobrang laki na. So, this is still out of phase by 180 degrees, na itong green sine wave na to, and amplified na sobrang taas. So, as you notice here, nasa around, na siya, no? Negative, probably nasa 36 or something, no? But nevertheless, no, ito yung comparison between the outputs of the unbypassed and the fully bypassed configuration. So sa unbypassed, mababa ang gain but stable, but sa fully bypassed, mataas ang gain but it is unstable compared with the unbypassed one. Kung meron kayong mga katanungan, i-post lang sa ating group chat and I'll try to answer it as fast as I can. So that would be all, and thank you. Have a nice day.